Hello, fellow hackers. Brypone here, back with another one. Today, we're going to take a look at a utility called Nativedump. Nativedump is a different variant of an LSASS dumping utility. Nativedump doesn't use the default minidump write dump API call. So what it does do is it takes and it pulls different parts of the processes that are open, and in some cases overwrites different processes to essentially create its own minidump file. So instead of calling minidump write dump, which is what most EDRs trigger on, it creates its own. That's novel and awesome. But, well, the initial go of this is in .NET, and what happens is Defender started eating it. Of course, that's normal. But what Defender did not start eating was some of the other flavors of this, in particularly the Golang flavor, which we're going to set up here and test in just a moment with Defender fully functional. We're just going to dump LSASS right by it and send it to another host. It's also a Python flavor, which I have not tested. This one in particular looks interesting if it works as well as the Golang flavor. It might even be better than the Golang flavor because Python's a little bit more pervasive. You might not have to install Go. But in general, these two are promising. I know Golang gets by Defender, though, so that's what I want to show in today's video. There are other flavors as well. The remote flavor of this works a lot like the Golang version. The remote version, you can do string AES encryption and XOR encoding. So in these cases for remote and main, if you wanted to stick with .NET, you can just obfuscate it to get it by Defender. Initially, these weren't detected at all, but they have started being detected here in recent versions. But doing some simple obfuscation, obfuscating some of the different libraries it's reaching for, you should be able to get this one by. Okay, so let's take a look at our Golang flavor of Nativedump. So over here, we're going to start with our Windows workstation. And I know you're like, where's Kali? Well, I'm not using it in this demo. We're going to use Windows. The reason we're going to use Windows is to decode the dump file that's coming out of Nativedump. PyByCats didn't work. It was looking for a UTF-16 LE. That was the error that I got. So normally I'd send it over to Linux, but in this case, it doesn't work. So we're going to use Mimikatz and Windows. And this is my malware dev host that I usually build projects on. So we're just going to use that as our receiver. So we're going to use Ncat. This is basically Netcat for Windows. You could also use PowerCat here. PowerCat is the PowerShell version of Netcat. It'll do basically the same thing, but essentially what we're going to do is we're going to set up a listener here on port 1234, and we're going to create a file called exfil.dmp or dump, right? In this folder, we have our variant of Mimikatz, an obfuscated variant. I don't really have to obfuscate it because I'm in control of this host, but we're going to have Mimikatz in this same folder, and we'll run that here in a minute. But let's go ahead and start our listener. And we can see it's now listening because it's progressed to another line. And then we're going to come over here to our victim host. Our victim host is our typical user. If I go from AMI, we can see that it's Clint Barton. We also want to take a look at Defender here because, as I said, Defender is fully on. We're all green here across the board. If we go into our settings, we can see real-time protection, cloud delivered protection, automatic sample submission, and tamper protection are turned on. So this is default Defender, not Defender for endpoint, but that's what we encounter in a lot of these engagements, right? So default Defender works like a champ. So we're going to take and we're going to run Nativedump. So Nativedump, I have pre-compiled the Go module essentially, or Go script into an executable, right? So it's an executable, it's portable, it can be used. You don't have to do this. You could literally just download the Go script and run it with Go, right? And then just do Go nativedump go, and then give it the same stuff, the -i, the IP address here, and the port. But this is a compiled executable version, so we've got nativedump.exe -i 192.168.136.56, which is the IP address of our host, and then our port that we're going to send to. So let's go ahead and run this. As we have shown, Defender is fully on. And here we go. It has found the process ID for LSASS. Made sure I had the right privilege. You do have to be an admin level privilege because you need the SE debug privilege to read LSASS. This is the case with all LSASS dumping utilities, right? Can't dump LSASS as a regular standard user. You just can't. You don't have the privileges necessary to do it. Process handle. This is the handle that it created, the number of modules, module stream size, memory list offset, and memory size. So this is just information of where the LSASS process was. And then it says file exfiltrated. Okay, well, that looks like a successful run. So if we come over here to our Hunter host, we should have, yes, it ended, right? So when it ends, you know you have the file that you're looking for. So if we go dir, we now have an exfil.dmp, and we can see that this is about the size of what we would expect for an LSASS dump. So it looks like we were successful, but let's prove our case. So in this folder, I have mini dogs, which is just an obfuscated version of Mimikatz. It gets by a whole bunch of EDRs. So I'll run my mini dogs here, and you can see this just runs Mimikatz. It's an older version of it. But we will do our loading of our exfil.file. So I'm not going to do privilege debug here. Without privilege debug, I couldn't be dumping what's on this host, right? I'm going to do sec URL SA, and then I'm going to do mini dump. And then I'm going to give it the name of our exfil.dump file. So exfil.dmp, just like we have right here, right? So we're going to go ahead and switch to that, and it should say switch to mini dump, and it does. It says exfil.dmp we have switched to. And now, quite simply, we're going to do sec URL SA again. And now we're going to do logon passwords. And it's going to scroll through, but the first thing you're going to notice is host to win $10. That is a machine account, right? So if I open another command prompt here, and I did it before, you can see host name Hunter Station. I'll do it one more time. Hunter Station, and then who am I? Over here, I'm a different user at a different station than what is being shown by this dump. So I didn't just accidentally dump my local system. I have successfully dumped LSASS, sent it across the network, and I have hashes from that particular machine with Defender fully running, which is pretty amazing, right? Amazing that this still works in 2024. But here is our user Clint Barton. Here's his NTLM hash, his SHA-1 hash, and his DPAPI hash. So you could pass this hash now, right? If this was a domain admin or something that had higher level permission that had logged into the system, you now have that hash, you can pass the hash. So what does this mean? If you're not running Credential Guard, stop the video now and go turn that on, because that's the only way you can stop stuff like this, right? As long as LSASS is running on the system and has credentials in it, attackers like me, like many other people, are going to find ways to get this out of the system, right? I've shown techniques where you just grab all of memory. Now I'm showing you a technique that just uses Go. It uses a different language that EDRs don't process well, right? EDR bypass is a consistent thing. There will always be methods to bypass EDR. So if these credentials mean things to you, you absolutely should have Credential Guard, because then they're just not on the box. They're in a virtualized container, right? So go do that. That's really your only defense here. Outside of that, making sure that you know in your network where you have languages like Go and Rust installed, because if an adversary suddenly installs Go to do this, you probably detect that, right? It's not normal in a lot of environments. In some penetration tests, you'll find Go installed on admin workstations because they have applications that are running in it. But these languages that are not the typical C, C Sharp, Windows coding languages, .NET, you're going to find that they get by EDR pretty regularly. There's also ways you can use WSL to do this kind of stuff where you have a Linux variant that's running on the host that can read files and access processes. So all those techniques are worth taking a look at, but the real answer here is doing Credential Guard. And that's all I have for you this week. If you guys want to catch me live, I have an upcoming SANS class. It's SANS Big Easy. That'll be running in late September. So check that out if you want to catch me live, and I can show you some of the techniques that I don't publish to my YouTube channel because I need them. So I publish the techniques that I think are, out there, but I've got some stuff that I only show in my SANS classes that would help you as a penetration tester or as a red teamer or blue teamer. So I show those demos in class. But come check it out if you get a chance. SANS Security 599. It is defending against advanced threats. So come check that out if you get a chance. Outside of that, I'll always say, hack the planet to defend better.